In the first example here, we have an example of buying shirts in a store. So in a store, out of all the people who came there, 30% bought a shirt. If 4 people came into the store together, then find the probability of one of them buying a shirt. So what we need to take a look at is the probability of an event occurring in general. The probability, I'll just call it E. In this case, E is the event of buying a shirt. So the probability that any one person buys a shirt is 30%. So this is 0.3. All right, so that takes care of this fact. Now I've got 4 people that come in, and I want to know how many different ways one of them can buy a shirt. So if I take a look at that, the binomial probability equation I saw before, I want to know the probability of the event occurring exactly one time, since I want to know one of them is going to buy the shirt out of 4. And since I've got 4 people to choose from, and I want one person choosing that shirt or buying that shirt, I want to know all the different ways one person out of 4 can buy that shirt. And so that's going to be, my n choose r is going to be 4 choose 1. And that's going to be multiplied by the probability of success, 0.3, to the power of the number of ways that I want this success to occur. So there are 4 people, and I want only one of them to buy the shirt. So that basically you can think of that as I'm successful in selling the shirt once out of those 4 times. So that's going to be a probability of, or an exponent of 1, since there's 1 success. The probability of failure is 0.7, so that's going to be raised to the 3rd power, since I have 3 other people not buying a shirt, so these would be like the number of failures that occur. So again, just to kind of reiterate where those numbers come from, the number of successes is 1, since one of them buys a shirt. The number of n trials equals 4, and and I guess the successes, that's also equal to my r. So that's where all the n's and r's come from. So this is my n choose r, 4 choose 1. Here is my exponent for successes, and here is my exponent for failures. And I guess I could say failures equals 4 minus 1, which equals 3. So now to actually figure out what this probability is, I'm just gonna type stuff into the calculator. So I can actually type this in just as it's written. So I'm gonna go back to my calculator, and I'm gonna go to math. I'm gonna go to probability. I'm gonna go to the NCR. That's the 3rd option, and I want to type in 4 choose 1. And I'm going to multiply that by 0.3 to the 1st power times 0.7 to the 3rd power. And when I hit enter, that should give me a decimal here. So the probability of one person out of this 4 walking away with a shirt is 0.416%, or 0.416. Oh wait, was there another one in there? Yeah, 0.4116. Or I can round that to 3 significant figures and say 0.412, or about 41.2%. That's the probability that one person out of 4 buys the shirt if 4 people walk in. All right, so that was a little bit of a tricky example. Got a lot of pieces to break down. Now, what might be kind of interesting is that this is actually higher than 30%. So even though there's a 30% chance of just one person buying a shirt, if you want 1 out of 4 people to buy a shirt, your odds or your probability actually increases a little bit. So that's what's kind of unique and interesting, I think, about this binomial probability stuff. It's not just a straight, here's your chances. You kind of have to actually do the math out, as they say. So why don't you try this example here. It involves choosing chicken, I guess at a restaurant or something like that, and work out what the n is, number of trials, work out what the success probability is, work out what the number of successes you're looking for as well, and see if you can't figure this one out. So pause the video, give this one a shot. All right, so the probability of the event occurring is 0.7, since 70% of people choose the chicken, and I want to know how many different, or rather I want to find the probability that that event occurs 7 times. So since I have n trials, since I have 10 trials out of 10 people, and I want to find the different number of combinations of choosing 7 of them for 7 of these customers for success, I'm going to multiply that by my probability of success to the 7th power times the probability of failure to the 3rd power And after typing that in my calculator, I get this. So I would be good with a number of 0.267 as my probability.